Okay. So you can see the screen now. Okay. So this is about the unconditional optimization, in which we will be having the dichotomous as well as golden section method. Okay. So in the case where we will be having the dichotomous method, in the dichotomous method, these are all the principles, or these are all the steps which we are going to adapt. So in the case of dichotomous search method, we will be computing the midpoint, okay, a plus b by 2, and then we will be moving slightly from the midpoint towards the right as well as towards the left, okay, by incrementing it by delta, where delta is a very small value or else the number which we will be using, and the objective function which is there, that will be placed between these two set test points as close together as possible, and we will be computing the optimal solution. So that is the methodology we will be sticking on to for finding the optimal value in the case of dichotomous method. So in the case of dichotomous method, we will be considering two such variables, that is ck as well as dk. So ck is one. Can you hear me, ma? Students, can you hear me? Okay. So in the case of dichotomous method, we will be sticking on to two such parameters which are there, that is ck as well as dk. Okay. So in the case where we will be having ck, it is calculated as ak plus bk divided by 2 minus delta. Okay. Delta is the value which is provided over there, and ak plus lk, it is also that is alternated as ak plus lk, which is the previous value which is there, divided by 2 minus delta. So dk is also we will be having the same term plus delta. So we will be incrementing by in the with the help of the delta value towards the right, as well as moving towards the left. That is the meaning. And here we'll be determining the new interval in the way which we'll be adapting, like if the value function of ck. So first we'll be finding the value of ck as well as dk. After finding it, we'll be substituting that particular thing in the objective function. Okay. And from there, we'll be getting function of ck as well as function of dk. And after finding that, we need to check with whether that particular ck which is greater than dk, or else it is less than or equal to dk. Okay. If it is falling with greater than f of dk, what we need to do, then the new uncertainty interval is ak plus 1 comma bk plus 1, which is equal to ck comma bk. If not, it is the function of ck which is less than or equal to function of dk. Then the new uncertainty interval which is there is ak plus 1 comma bk plus 1, which is equal to ak comma dk. Okay. So that is the way we will be computing the next values which are there. Okay. So afterwards, we need to find the length of the obtained interval which is there. Okay. LK plus 1. Okay. Every time we need to find the new length. So for finding the new length, we need to check with, that is the equation for that is LK plus 1, which is equal to LK by 2 plus delta. Okay. So we need to continue till the LK value, that is the length which we will be obtaining, which is less than or equal to 2 into epsilon. So epsilon is the value which will be provided over there. So every time we need to cross verify whether the LK value which we will be getting, that is less than 2 into epsilon or not. Okay, if it is epsilon, which is that is, if the value was falling between, that is behind it, then we need to consider that, and with that we need to stop it, and we need to find the final x-min value which is there. So this is the algorithm, the same thing which is projected as an algorithm. Okay. And here, this is the problem which we will be dealing with for finding the optimal solution for a problem which is there using the dichotomous search method which is there. So determine the minimum point of the function f of x equal to x square minus 7x plus 12, which is the minimum one with dichotomous search method, where a and B is given at first. So A value was 2, B value was 4, delta value was 0.3, and epsilon value was 0.4. Okay. So after finding it, we need to go to the first step. In the first step, we need to take the values as such. That is, what are all the values which is given? That is A1. Okay. A1 plus A1 plus A is 2, B is 4, delta value which is given, that is 0.3, epsilon value which is given is 0.4. Okay, so the first interval A1 comma B1 is 2 comma 4, where the length L1 is 2. Okay, so we will be getting with the values which is here. That is the first value, that is A1 value, we will be considering here as the any doubt, ma? Okay. So L1 value was 2. Okay. Now what we are supposed to do, we need to consider the 2 test points which are there. So for which C1 we need to find. So what is the method which we will be adapting for C1? So already we have given a particular set of procedures there, right? So CK, which is equal to AK plus BK divided by 2 minus delta, which is also equal to AK plus LK by 2 minus delta. Okay, so that is the equation which is given. So based on which we need to find with a set of values. So C1, which is equal to AK, that is K value here is 1. Okay. So A1 plus L1 divided by 2 minus delta. So what is A1? A1 is 2 plus L1 value is 2. 2 divided by 2 minus delta value is 0.3. Okay. So when we will be dividing 2 into 2, we will be taking whole thing which is divided in the case. So when we will be dividing, we will be getting 2 into 2 plus 2 minus 2 into 0.3. So divide the whole divided by 2. So when we will be getting 6 minus 0.6 divide the whole divided by 2, which will give you 2.6. 3. Likewise, it will be moving on. So we will be taking it as 2.7. Okay, that's how we arrive at 2.7. Now what we need to do? We need to put that particular value in the equation, that is in the f of x. So instead of x, we need to place 2.7. So 2.7 square minus 7 into 2.7 plus 12, which will give you 7.29 minus 18.9 plus 12. Okay, which will give you the value 2.7 is which will give you the value like 0.39. Okay, and again we need to find D1. Okay, so when we'll be finding D1, A1 value which is 2 plus L1 value which is again 2 divided by 2 plus 2 into plus the value which is there in delta, right? Delta value was 0.3. So which will give you 6 plus 6.6 divided by 2, which will give you 3.3 as the answer. Okay. 6.6 divided by 2 will be coming when we will be dividing the thing, which will give you 3.3 as the answer. Okay. So afterwards, what we need to do? We need to find f of d1. Okay. So the function of x, instead of x, we will be substituting the value 3.3. So which is equal to 3.3 square minus 7 into 3.3 plus 12, which will give you minus 0.21 as the answer. Okay. Now, what we need to do? We need to check what is the next condition? Whether f of ck, which is greater than f of dk, or else which is less than or equal to dk. So here we can check when we will be checking f of ck, that is c1 value which is greater than f of d1. So if it is greater, what is the thing? Ck comma bk will be the value. Okay. So ck value, c1 value which is there, comma bk value. Okay. The bk value was 4. Ck value was 0.39. So we will be taking as such. So 0.39 equivalent to that is C1 value is 2.7, right? So 2.7 comma BK value is 4. Okay, we have taken as such for A2 as well as B2, which is having the length. Now we need to compute the length. What is the length which is computed? LK plus 1. That is the formula which is there, right? LK plus 1. Yes, LK plus 1, which is equal to LK divided by 2 plus delta. So what is our LK? LK value is 2 divided by 2 plus delta value is 0.3. So whole divided by, when we will be making, we will be getting 2 into 2 plus 0.6. That is 2.6 divided by 2. Right? So we will be getting 2.6 divided by 2, which will give you 1.3. Okay. Now we have found L2 value also. Now, in the same method as how we applied in the previous case, we need to do. So what is our C2 now? 2.7 plus 1.3 divided by 2 minus 0.3. Okay, so it will give you 3.05. So when we will be substituting f of 3.05 in the first equation. Okay, here when we will be substituting, we will be getting, that is, what is the value? 3.05 square minus 7 into 3.05 plus 12. Okay, when we will be making the simplification, we will be getting the answer like minus 0.0475. Okay, again we need to compute D2. Okay, so when we will be computing D2, we will be getting 2.7 plus 1.3 divided by 2 plus 0.3. That is the delta value which is there. Okay, so which is equal to 3.65. That is the answer we will be getting. So when we will be making f of d2, which is equal to, now we need to substitute 3.65 in the above equation. So when we will be substituting, we will be getting the value like 3.65 square minus 7 into 3.65 plus 12. Okay, so when we will be computing there, we will be getting the value like minus 0.2275. That is the answer we will be getting for D2. Okay, now what we need to do? We need to check. What is the thing to be checked for finding the LK value, whether to proceed or not? That is LK value which is there, that is less than 2 epsilon. That's what we need to check. Okay, so what is the LK value which we arrived there? So we will be checking here whether the LK value which is there in the next step. That is, again, we need to find that is f of C2, whether it is greater than D2 or not, or else it is less than or equal to. So here when we will be checking f of C2, which is greater than f of D2. Okay, so now the uncertainty will be what is the CK value divided CK value comma BK value. Okay, the CK value which is there is 3.65. Okay, okay, yes. And we will be checking. We will be getting the C3 value was is 2.7, comma, instead of BK we will be using this. Okay, that is 3.65. Now what we need to do? We need to find the length. Okay, so for computing length, what is the formula? LK plus 1, which is equal to LK divided by 2 plus delta. So the delta value is 0.3. LK value which is previously is 1.3. Okay, so 1.3 divided by 2 plus 0.3, which will give you 0.95. So now what we need to do? We need to check whether 0.95, which is less than 2 epsilon. Okay, so what is the 2 epsilon value? 2 into epsilon is given in the thing like 0.4. Right? 0.4. So 0.4, which will give you 0.8. So 0.95, which is not less than 0.8. Okay, so we need to continue further. So when we will be continuing as such in the finding the CK as well as DK, we need to find the values like 2.875 as well as 3.475. Okay, when we be substituting in the function of x, okay, which is given here, x square minus 7x plus 12. In that, when we will be substituting, we will be getting the values of f of C3 as 0.140625 and f of D3 as minus 0.249375. It is a lengthy one. Okay, so now what we need to do? We need to find again the next thing. So we need to check like whether the C3 value is greater than D3. Okay, so here it is following that. So we'll be finding the next value, that is 2.873. That is the C3 value. And 3.65. That is the previous value which is there. Okay, so we have replaced it and we have found the length of 4 is, that is what is the length equation, that is LK by 2 plus delta, right? LK value is 0.95 divided by 2 plus delta value is 0.3. Okay, so we need to find it. Here the value which we got is 0.775. We need to check again whether that value was less than what is the value which is given in epsilon. So 2 into epsilon, 2 into 0.4, which will give you 0.8. Now we can see this 0.775, it is less than the 2 into epsilon value. Okay, so 0.8 is the epsilon value which we will be getting, 2 into epsilon value. So 0.775, which is less than 0.8. Okay, so we need to stop here and we need to find what is the interval, small enough interval value, which is L4, which is less than 2e, and the approximation value which we will be getting is, when we will be counting here, we will be getting the x-min value was 3.2625. Okay, so we need to find the exact value. So when we will be checking the exact value, we will be getting x dash equal to 3.5. That is the interval which is intermediate to it. Okay, so this is how we need to find the total value which we will be getting. Okay, so I'll be repeating it. At first, we need to find the total value, that is the optimal value using the dichotomous search method. So for which we need to find two possible measurements like CK as well as DK. Okay, so now when we will be checking here, AK plus DK divided by 2 minus delta, and the other one is AK plus BK divided by 2 plus delta. Again, we can simplify this equation as AK plus LK divided by 2, that is length divided by 2 minus delta, and AK plus LK divided by 2 plus delta. Okay, so now after finding this, we need to check the condition whether CK value is greater than DK, or else the function of CK value is less than or equal to function of DK value. If so, accordingly, we need to place it. Okay, and also for finding the next length, we need to find it as LK plus 1, which is equal to LK divided by 2 plus delta. Okay, so we need to continue until we'll be reaching LK value which is less than 2 into epsilon. Okay, epsilon value will be provided in your problem. So here we'll be having the finding the minimal point of the function. So for which function of x which is given with dichotomous search method, we need to find where a and b value, initial values are 2, 4, and delta value was 0.3 and epsilon value was 0.4. So at first we will be finding the first interval with the given values. When we will be providing it, we'll be finding C1 as well as C2 as 2.7 as well as 3.3. Now we need to substitute these values to function of x. Okay, instead of x, we need to place the C1 as well as D1 values which are there. So accordingly, we need to find it and we need to check with whether the C1 value which is less than or equal to D1, or else it is greater. So if it is greater, we need to give the values like, yes, AK plus 1 which is equal to CK, and BK plus 1 which is equal to BK. Okay, so accordingly we need to provide for each and every case, and each and every step we need to find whether the value which we have arrived for L2, that is the length, which is less than or equal to 2 into epsilon. Okay, if it is less than, we need to stop thereby, and we need to provide what is the x minimum value and the nearest value which we will be getting as our exact point of the function. Have you got it? Okay, I'll be sharing this in your Google Classroom. Take this in your note, and tomorrow I'll check it.
Does anyone have any thoughts on synchronization? So, to start taking this immediately. Jebin, Jebin, Jebin.
Yes, I have posted as module 4. You can copy down from there.